Okay, we can start. Not going to waste the time. Okay, we have can you see the screen right? We have done number 1, number 2, and number 3, and number 4. We're going to continue with number 4. An object with an object of mass 2 meter with 2 meter. Object of mass is I show from kind slide. Okay, mass of 2m. Moving with kinetic energy K collides with stationary object of mass m after collision object coalesce. Okay, it means that it merged together and moving in the same speed. What is the loss of kinetic energy due to collision? So, what's your answer? Everyone, have you?
B.
Answer is
Boy.
boy.
Oh, he finally returns. After so long of silence, he finally returns. The legendary
Major comeback, bro. It's a major comeback.
Okay. Any more answer?
It's B, sir. Definitely B.
Anyone answer others?
It's okay, sir. This class right him only, sir. Don't worry.
Okay, let's try. So K
No, sir.
is half mv squared, right? Half mv squared. So in the question it says that it stated that it is 1 over 2 and 2m times u squared. Correct or not?
Yep. K.
So conservation of momentum, and mass number 1, v number 1 equals total of mass before equals to total mass after, right? The total momentum before m1u1 plus m2u2 equals to m 1 plus 2, m1 plus m2, and common velocity v, called as common velocity. So we have actually what we have is 2m plus m times with v equals to 2m and times with u. Okay, actually this is I inverted. This is after, this is before. Okay, and if you arrange back, v is equals to 2u divided by
over
3.
3.
Okay, so how much is kinetic energy? Kinetic energy is equals to 1 over 2 3m times with, this is mv squared, right? 2u divided by 3, and this is square, so this is m, this is v. So how much kinetic energy loss is, you have to minus, right? So kinetic energy minus the loss, that is 2 over 3 k, right?
1 over 3.
So answer is 1 over 3. So answer is A. Okay, correct answer is A.
Major comeback.
Setback, sorry.
Major comeback.
Okay.
It's a setback.
Okay, question number 5. In hydroelectric power
Damn
station,
confident, you know the first answer.
water falls to a height of 120 meter at rate. This is, what does this mean? M3 meter cube over time.
Second.
So this is d
Volume per second.
v over dt, right? Whole thing is dv over dt. It determines what the power input of the power station. So what would be the power input? So power will be, so power is,
I put C. So.
You put C?
Yeah, put C.
You put
I don't
C?
know why, but I put C.
How do you put C? Okay, actually C. Let's see.
I just put there as a
okay,
C.
Power equals to work divided by time, or energy divided by time. So this is mgh. It's a work or energy. Okay, mgh divided by T.
I use density.
later we go use this m over t times gh. Okay, gh. So you have 600, okay, times with 10 power 3 and times with g 9.81 times with one more, that is 120 watt.
Wait. 1000 times 600.
So density is mass over volume. So there you have mass is equals to divide density times with the volume. So this is density, this one will be the volume. This is density, this will be the volume times with g and times with h. So if you calculate everything, you have 710 megawatt.
Yeah.
Okay. Number 6, a coin of mass is placed on the horizontal turnable rotating at constant angular velocity omega. The maximum friction force between the coin and the turntable is this is 1 over 2. So frictional force is 1 over 2 mg. The maximum, okay, first I have to draw, if not you don't understood. Okay, this is a turntable. Okay, the table can be turned. So there will be a coin on the table. So there will coin over here and the turntable will be rotate. Okay, rotate. In this axis it will be rotating. Okay, so there will be a speed in omega, okay, that the coin will be slip. Okay, will not be going there, it will be relative uh, velocity between them. Okay, now so frictional force is half mv squared. Okay, half mv
Answer is donkey, sir.
1 over 2 mg. Yeah, so this is frictional force. Frictional force is
Equal
equals to
to
force of
centripetal
centripetal force.
force.
This is frictional.
Yeah.
This is centripetal. So if the frictional force is lesser than centripetal,
That's
frictional
donkey.
force is lesser than friction centripetal. So they will be starting to the coin starting to slip. Okay. So there we have. Okay, I'm going to erase. So we have F equals to 1 over 2 mg and equals to mr omega squared.
RW square.
Okay,
Yes.
mr omega squared. So r, the radius will be g divided by 2 omega squared. So answer is
Donkey.
D, donkey.
Look, sir, I'm feeling the comeback.
Okay, next. Question number 7. Oh, any question on
Nice, ignored.
6? Any question on question number 6?
No.
Okay.
I did correct. Okay.
Okay, question number 7. Gravitational potential between the surface of a planet at a point 50 meter above is 300 joule per kilogram. So we have a surface of a planet and it says that above 50 meter, which is not actually, this is this is simple drawing. 50 meter is very near actually. Okay, above is at this point, the V potential difference is 300 joule per kilogram. Okay, we assume that gravitational field is uniform. What is gravitational field strength? Okay, gravitational field strength. So from the formula that we know, G is actually negative change of potential divided by change of the distance. Okay, so this one we actually have 300 divided by 50. So the G there is actually negative 60 Newton per kilogram. So here we have here. Okay. V of X. Okay.
The force on the ladder. Oh,
The ladder of weight rests W rests in equilibrium on the loft floor against smooth wall. Which one you pick? A, B, C, D.
uh, boy, I guess.
Boy. Tony?
Wait.
I pick A.
A. Boy A. Anyone? Mayway?
A is a A. I said A.
Jeremy says A.
I don't know, sir.
Boy so
We
says
say
A.
A. Jeremy say B, sir. He lost already.
C and D?
Yeah,
Why you didn't pick C and D? Nobody picked C and D. The reason
Because
is
they wrong one.
maybe also A.
wait,
wrong answer.
Why C and D is out of the equation?
Because they're wrong, sir.
wait.
So the X
Eh,
cacat.
no.
X chart.
X is
Yeah.
perpendicular.
Okay, why we didn't pick C and D? Because
The extra chat.
X chart. Okay, he says yes, he has rough floor and smooth wall. If we have a smooth wall, the X should not be
Chat.
diagonal.
Yeah, A lah.
It must be uh perpendicular to the wall, right?
Wall.
So the answer should be only A and B. Okay. So this one, which one? A or B? X is already correct in this side. Okay, W also correct because W of course is pointing down. So now you see that because it have a rough floor over here, so it cannot be pointing up like this. Because if you know that when the ladder goes to the floor, there will be one is the normal force and one will be the frictional force. So normal plus frictional, there will be as reaction force, right? Okay, so B cannot be the answer. So this one cannot be because Y is actually in this case is the normal force. Okay, one more reason is actually if you have anything that is equilibrium, the triangle of the forces uh, must be cancelling itself. Means that this one pointing up, this one pointing diagonally to the right, and this one pointing down. If you check A over here, Y is pointing up. This is Y, and X is pointing here, and this is X, and W is pointing downwards, directly downwards like this. This is W. So you can see, yeah. Can you see? X, W, and Y are in the triangle. Okay, if you have B, if you select B, the triangle cannot be complete. It will not be a triangle. You see, this is Y pointing up, and this is X, and W is pointing here. Can you see? You can. This is not a triangle. Okay, you can only have a triangle over here. It happens only in
But
equilibrium.
but if without the frictional force is B, right? So
Without the frictional force, if without the frictional force, the ladder cannot be stand, right? You cannot put a ladder there. Must
Can
be
answer.
either of them. Must be there will be a rough, surface. Okay, so the
So you
answer
see the
is A.
question physics question all say don't have one. I think before.
Okay, so the only answer is A. There are two methods you can use to determine which one is the answer. C and D is out of the answer. Cannot be. Okay, so answer is A. Force constant of wire of length L, diameter D is K. Okay, so we have a wire of length L. The length is L. Diameter D. So force constant. What is the force constant formula?
Force constant.
Force constant of a wire.
F over A or something, is it?
Answer is A lah, sir.
So force constant F equal KE. This is force constant for the wire F equal KE. And remember,
Oh,
we
yeah,
did
yeah.
learn that we can substitute K as Young modulus times A divided by L. Yeah.
L, length.
So Young modulus times A divided by L and times E. So there you have K equals to Young modulus times A divided by L. Okay. Because E over here cancel with E over there. Okay. So you have K equals to Young modulus times A over L. So K now it says that the force constant of another wire same material but length is 2 times, means that it's longer 2L, and diameter is smaller 0.5, half of it. Okay. So when we have a K prime, it means that the new force constant of the wire will be Y. That means that the Young modulus A divided by 4, Y divided by 4.
D A divided by 4.
D square. So
diameter divided
D
by square.
over
Divide by
D,
2.
Yeah, what he
Then
said.
you square it to get 4.
Okay. So that's why you divide by 4. Area divided by 4. Okay. And then divided by 2L. You have 2I right in the second situation. The second. And then if you cancel everything, you have a K divided by 8. So it means that over here you have Young modulus times A divided by 4 times with 2 times with 2 there. Okay, so you have 1 over 2, sorry, 1 over 2. So there you have 4.
Is the picture lah? Oh, this floor.
Okay, so K divided by 8.
Yeah, A.
Okay. Next, for the force extension graph of wire is plot, what is present by the gradient of the of the graph. So we have force extension for this is force
Young's modulus.
extension. So it's a Young modulus.
Young's modulus.
Are you sure about that?
F divided by E equals to K. And K is actually force constant.
Strain energy and force constant same. Correct lah.
Okay. K, you cannot say K as Young modulus because K is actually
K is strain energy, right, sir?
divided by K is actually divided by L. K is not Young modulus. K is not Young modulus. K is equals to Young modulus times A divided by L. So answer is B. 11. The gas in a closed vessel is heated. Which reason increase the gas pressure? Okay. Why? We have a vessel over here, and then we heat up the vessel. Okay. Which reason of the increase in the why the pressure goes up when they increase the temperature? Very easy lah this one. 11.
Teacher, of course, easy lah.
Okay, let's see. A. The gas molecule expand. Can we use that thing? If you remember the assumption of ideal gas equation,
is negligible.
yes, this one cannot be used. Gas molecule travel faster and collision between gas molecules increase. This one also, there are no intermolecular forces between the gas, right? In the assumption of the gas equation. And then, if the collision between the gas, the pressure will not be increased. How do we measure the pressure of the gas? Is because the molecules of the gas to the wall, not between the collision the gas to the molecules of the gas to the gas itself. So C, rate of collision of gas molecule with the walls increase. This one correct. Number of gas molecule and rate of collision between molecule increase, also not. The gas pressure is when we measure how much the momentum of the gas towards the wall of the container. It doesn't account for the gas collision between the gas or the gas molecules between the molecules. We only measure to the wall of the container. So answer is C. Obviously, A cannot be used. A closed vessel contains 2.5 moles of either atomic gas, diatomic. Okay, it means that you are playing with the gamma or playing with the degree of freedom. What is the heat required to raise the temperature of the gas 30 to 35 Celsius? Answer is
喂，没有，don't swear。
number 12. So CVM equals to CVM.
So these are troublesome. If it's a chapter about CVM, all these are trouble.
Okay, CVM is F over 2R. Okay, so F how much? Diatomic?
5/2.
Okay, 5 over 2 R. So 5 over 2 R is R is 8.31, right? So if you calculate everything, this is 20.8 joule per mole per Kelvin. Okay, so it says that the Q equals to NCVM constant volume. Yeah, it's constant volume. And change of T so you have a number of mole is 2.5, CPM is 20.8 and times with 5 because the change difference of temperature is 5, then you have 260 joule. So answer is B. Okay, number 13. A fixed mass of ideal gas undergoes X.
So can I see them 12? Okay.
Okay. So fixed mass of ideal gas undergoes a change X to Y, X to Y, and Y to Z as shown in the graph. The heat supply of a gas, so it says that Q supplied to gas is 780 joule. What's the increase of internal energy of the gas? So what is the internal energy is change of U. Okay. So now we have two process, X to Y and Y to Z. So X to Y, work done is work done W equals to P change of V. Okay, so 1 times 10 power 5. You can see on the, you can check on the graph, and 8 minus 2 and times 10 power of 3 joule. So you have 600 joule. Okay, so over here, down here, an area on the graph is 600 joule required. Now Y to Z, it doesn't increase. The volume does not increase. Okay, so there actually no work has been done. So Q equals to change of U plus W, and change of U internal energy is 780 minus 600 and joule, right? Because work is 0, right? So there you have 180 joule. So answer is 180 joule.
So why is 780 minus 600? Why is 780 minus 600? Where did the 180 went?
780.
Where, yeah, 780 minus 600, right? So where did the 180 joule go in the graph?
180 joule?
Yeah.
You mean this one answer?
Yeah.
No, you cannot check. This is internal energy. We are counting the internal energy of the gas, not the work by the gas.
Okay.
Okay, work is the different thing. Internal energy of the gas is different. Remember, Q equals to internal energy plus the work. Second part, work is 0. It's only have internal energy. Q is the supply, heat supply. Okay. Number 14. The temperature of 4.0 moles of ideal gas cylinder is 300 K. The gas explains isothermal expansion. Isothermal means that? What does it mean, isothermal? Isothermal
No change
means
in temperature.
no change of temperature. Okay. Expansion twice its initial volume. So V1, this is 2V1. Okay. And isothermal means that in this curve. What is the work done by the gas? So when talking about work done by the gas is area under the graph. Okay, so PV equals to nRT. So P equals to nRT divided by V. Now work is the integration of the area under the graph to V divided by V, and P dV. So you just getting the area under the graph. So 2V and V and RT divide the V dV goes to the other side. So nRT ln V, 2V and V, this is work, and you have 4.0 times with 8.31 and times with 300 and ln 2, okay, ln 2. So you have 6.9 kilojoule. So 6.9 kilojoule over here. We just using maths to get the area under the graph of the isothermal curve. Okay, so the last question before we end today, we have only have 3 minutes. Which of the following contributes to global warming due to greenhouse? Who was presenting the greenhouse? Who is it? I forgot already. Who was it?
Maverick, sir.
Maverick. 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 Are you there? Maverick. Maverick. Is he here? Ah, it's AFK. Right. Yeah, kantoi. Okay, answer is there, Maverick.
Yes, sir. So I'm
Number
not
15.
Mav.
Huh?
So I'm not Maverick. I'm not Maverick.
Oh, where's Maverick?
AFK, sir.
FK.
Toilet.
Here, sir, here.
Okay, now you
Ah.
have. Number 15. With the following contributes to global warming due to greenhouse effect.
A, sir, A.
Ah, correct. It's A. Infrared radiation trapped by carbon dioxide in the atmosphere. B. Why cannot be? Maverick. Why cannot be?
Sir, it's not absorbed by the Earth's surface.
Hmm? Cannot be absorbed. C. Microwave emitted from equipment. No, this one is not. D. Radioactive radiation released
But
from
this
nuclear
one
power
is
source.
the fact, sir.
Huh? Can't hear you. What you said? Okay, so answer is A. Infrared radiation trapped by carbon dioxide at the atmosphere. So C is complete. Yeah, of course, C is completely wrong. D also completely wrong. Okay. Okay, we stop here. You have class
So
tomorrow?
you haven't explained why B cannot.
Ultraviolet radiation from the sun absorbed by the Earth's surface. B. Ultraviolet radiation. Somehow, I see that it will be increasing the Earth's surface, but it is not what we call as greenhouse effect. The I mean the meaning of greenhouse effect is because of the radiation, infrared radiation by carbon dioxide. Ultraviolet radiation can increase the Earth's surface, but this is we didn't call it as a greenhouse effect.
Okay, sir.
Okay. It's just the meaning of what is actually greenhouse effect. Ultraviolet radiation. So okay. Any more question? Any question? So we have finished the objective. Tomorrow we have a class or not?
I think it's Friday. So.
Thursday.
Thursday.
Thursday,
Okay, we
Thursday.
continue on today. We have section B. Make sure you do section B. Okay. Then we discuss section B. Okay. See you on Thursday.